Hello, today I'm going to be going over Unit 3, Lesson 6. You may be watching this on either Thursday or Friday. Today's objectives are students will be able to apply theorems to determine if lines are parallel, and students will be able to prove lines are parallel given angle relationships. Today we're going to look at different theorems and relationships. Let's begin. Again, this is Proving Lines Parallel, Unit 3, Lesson 5. I'm going to conduct a brief review of Unit 3, Lesson 4, Lines Cut by a Transversal. As you can see here, we have two parallel lines which are cut by a transversal, specifically line C. We're now going to look at the different angle pairs and their relationships. We're looking first at alternative interior angles. Let us remember that alternative interior angles are inside angles that are on opposite sides. Let's look at a set of alternate interior angles. I'm going to look at angle 3 and 6. These are two angles that are inside and on opposite sides. Angle 3 and angle 6. Angle 3 and angle 6 are also considered congruent, meaning they have the same angle measure. Let's look at alternate exterior angles. Alternate exterior angles are outside angles that are on opposite sides. A set of alternate exterior angles that we see here are 1 and 2. Angle 1 and angle 2 are alternate exterior angles. These angles are also considered congruent, meaning they have the same angle measure. Now let's look at same side interior angles. Let us remember same side interior angles are two angles that are on the same side and that sum up to 180 degrees. The same side interior angles that we can identify here are 3 and 5. Angle 3 and angle 5 are same side interior angles. More specifically, if we add angle 3 and angle 5 together, we'll get 180 degrees. Now let's look at another type of angle, and that is corresponding angles. Let us remember that corresponding angles are angles in matching corners. A set of corresponding angles in this diagram are angles 2 and 6. As we can see, those angles are matching corners. Angle 2 and angle 6. Let us remember that angle 2 and angle 6 are also considered congruent. Given this information, let us remember that all alternate interior angles are congruent. All alternate exterior angles are also congruent. And all corresponding angles are congruent. While all same side interior angles are supplementary, more specifically, they equal to 180 degrees when added together. There's a brief review of Unit 1, Lesson 4. Let's move on. Here's a brief review of Unit 1, more specifically, conditional statements. Let us remember that a conditional statement is a logical statement written in the form if, then. Remember that we had if, hypothesis, then conclusion. All conditional statements take the form if, then. An example of this might be if it is raining, then I will need an umbrella. Again, this sentence takes the form if, then. Let us remember that the converse is a statement formed by switching the hypothesis and the conclusion of the conditional statement. What this would look like is if we wanted the converse of the statement that we just wrote here, well then we would still have if and then, but we would actually switch the hypothesis and the conclusion around. Let me go ahead and move this so we can see it a little better. If I will need an umbrella, then it is raining. Or if I need an umbrella, then it is raining. That is our converse. As you can see, we have switched the hypothesis and the conclusion around. So converse statements take the form if, conclusion, then hypothesis. Let's see how this is applied in geometry. Here we have a conditional statement. This says, if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. There we have our hypothesis and our conclusion. But we can also write this as a converse, and that would look like switching the hypothesis and the conclusion around, so it becomes if two lines in a plane are cut by a transversal and the corresponding angles are congruent, well then the lines are parallel. All the different theorems that we looked at in Unit 3, Lesson 4 also have converses, and that's what we're looking at today. So our conditional statement is actually, if you remember, our corresponding angle theorem, which we looked at in Unit 3, Lesson 4. And our converse would actually be called the converse of the converse of the corresponding angles theorem. each of the different theorems that we learned about in Unit 3, Lesson 4, specifically 4 of them, all have different converses, and we're going to look at those today. Well, as we identified, we had the corresponding angles theorem, and here we see it again. Let us remember that in Unit 3, Lesson 4, the corresponding angles theorem appeared like this. If a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. Our converse, which we just learned, would look like if two lines in a plane are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. Well, why is this important? Well, it's important because in geometry, we are often required to prove different statements. And in order to prove different statements, we need to use different theorems. But in order to prove those theorems, we also have to prove the converse of those theorems to show that those theorems are true. That's how we get the original theorem and its converse. What you'll also see is that the original theorem states the theorem in its original form, and its converse works backwards to arrive at that same conclusion. For example, our corresponding angles theorem states, if a transversal intersects two parallel lines, then the resulting corresponding angles are congruent. I'm going to mark everything that happens first in red and what results in blue so that it's easier for you to see. So, this is saying if a transversal intersects two parallel angles, so we have a transversal which intersects two parallel lines, P and Q, then the resulting corresponding angles are congruent. So if we have a transversal which intersects two parallel lines, well then it's reasonable to assume that we have resulting corresponding angles which are congruent. The converse, on the other hand, states, if two lines in a plane are cut by a transversal and the corresponding angles are congruent, well, if those angles are congruent, well then we can reasonably assume from that our two lines are parallel. And that is the difference between the original and its converse. Let's look at our other theorems to look at the original, once again, from Unit 3, Lesson 4, and identify its converse. Here we have the same side interior angles theorem. Let us remember that this theorem stated if a transversal intersects two parallel lines, then the resulting same side interior angles are supplementary. What does this mean? Well, this means that we started with two parallel lines which are cut by a transversal. As a result of that, it's reasonable to assume that the same side interior angles are supplementary. The converse of this, on the other hand, states, if two lines in a plane are cut by a transversal and the same side interior angles are supplementary, well then it's reasonable to assume that those lines are parallel. So in this instance, we start by knowing that those two angles are supplementary, and from that we can assume that those lines must be parallel. I hope this is starting to make sense to you. Let's look at our other theorem. We have the alternate interior angles theorem. And this theorem states that if a transversal intersects two parallel lines, then the resulting alternate interior angles are congruent. So again, we start with two parallel lines being cut by a transversal. And from that, we can gather that the alternate interior angles are congruent. The converse, on the other hand, states, if two lines in a plane are cut by a transversal, then the alternate interior angles are congruent. Then the lines are parallel. So here, we start with our two alternate interior angles which are congruent. And because they are congruent, it's reasonable to assume that these two lines are parallel. Let's look at our last type of theorem. We have the alternate exterior angles theorem. This theorem states, if a transversal intersects two parallel lines, then the resulting alternate exterior angles are congruent. So, again, we start with our lines cut by a transversal. And because we have two parallel lines which are cut by a transversal, well then we know that our alternate exterior angles are congruent. Or the converse states, if two lines in a plane are cut by a transversal and the alternate exterior angles are congruent, well then the lines are parallel. So from here, we already know that our alternate exterior angles are congruent. And because of that, we can prove that P and Q are parallel. As you can see, in each of these theorems, we've identified that because we can reasonably assume the congruence, or the supplementary of that angle, so here we proved, because we know that the corresponding angles are congruent, well then we can prove that those lines are parallel. Here, because the same side interior angles are supplementary, well then those lines must be parallel. Here, because the alternate interior angles are congruent, well then those lines must be parallel. And here, because the alternate exterior angles are congruent, well then those lines will be parallel. So it is the converse which we use to prove that those lines are parallel. And that is why this lesson is called Proving Parallel Lines, because we use the converse of each of these theorems to prove that those lines are in fact parallel. Let's look at a type of problem that we might encounter. This problem states, if the measure of angle 4 is 60 degrees, then what are the measures of the other angles that make up P is parallel to Q and N is parallel to M? Well, we have been told that angle 4 is equal to 60 degrees, so we can substitute 60 degrees. Well, given the different angle relationships that we know about, well, now that we know that, we are looking for 1, 2, and 3. Well, from 60, we know that angle 3 is also 60 because those two are congruent to one another. So, angle 3 is equal to 60. Now, what about 1 and 2? Well, we know that 3 and 2 must equal to 180. The reason being is because they share this line. So we can substitute in the variables that we know. And see that angle 2 is equal to 120 degrees. Well, we also know that angle 2 is congruent to angle 1. And so 1 is also equal to 120 degrees. That is how we can use these different relationships to find unknown angle measures. Let's look at another type of problem. This problem asks us to solve algebraically for unknown values. It's asking us to find the value of x and y that would make line G parallel to line H. So we want to make line G parallel to line H. Well, let's see how we can do this. Let's first look for x. Well, we know that we have 90 degrees here. And because we have 90 degrees here, and because this angle and that 90-degree angle share that line, we know that the measure of this entire angle must equal to 90 degrees. Well, in order to solve for that, what we need to do is take 90 degrees minus 30, which gives us 60 degrees. So the measure of this angle in between here is 60 degrees. Okay. Well, it's also reasonable to assume that this angle is congruent to this angle. So we would do 60 equals 3x, because here we had a 3x. So we'll divide and find that x is equal to 20 degrees. Now let's look for y. Here we have y. Well, we can see that y is actually equivalent to this angle right here. And so what we want to do is add that entire angle, 60 plus 90, to find out what y is. 60 plus 90 equals 150, equals to y divided by 2. Y is equal to 75 degrees. So we have 75 degrees. Y is equal to 75 degrees, but this right here is actually equivalent to 150 degrees. Today we reviewed different converses, specifically the converses of the different theorems we learned in Unit 3, Lesson 4. The converse of corresponding angles theorem, the converse of the same side interior angles theorem, and the converse of the alternate interior angles theorem, and the converse of the alternate exterior angles theorem. In doing so, we learned that we can use these converses to prove that lines are parallel. For example, we could say if angle 2 and angle 6 are congruent, well then lines A and B are parallel. So what we're doing is determining that those angles are corresponding angles, same side angles, alternate interior angles, or alternate exterior angles, and then using that information to prove that those different lines are in fact parallel, thus proving parallel lines. Today we went over different glossary terms. We reviewed alternate exterior angles, alternate interior angles, converse, corresponding angles, and same side interior angles. If you have any other questions or concerns remaining about today's lesson, please feel free to email me at my email. I am here to help you. I know you will have questions, so please do not hesitate to ask them.